Welcome to lesson 11.4 using geometric probability. We're going to use lengths and areas to find geometric probabilities. First though, we're going to do some review. We're going to find the area of a circle with a radius of 2. So that's 5.2 squared times 3.14. Oops. Press something wrong here. 5.2 squared times 3.14. Okay, so 84.9. And find the area of a right triangle with a hypotenuse of 18 and a side length of 8 inches. So in that case, we have to find the height. So we have to use Pythagorean theorem, 64 plus our height, which is going to be b squared, equals 18 squared, 324. So when I take 324 and I minus 64 from both sides, 260 square root is 16.12. And 16.12 times 8 divided by 2 is rounds to 64.5. Last warm-up problem, a rectangle with sides 4 inches by 5 inches is cut out of a square with side inches, 8 sides of 8 inches. Find the area that remains. So the square, 8 by 8, was 64. We're going to subtract out 20, and we're going to be left with 44. A bit of probability review here. Probability is not on the EOC. We can go through some of these problems though, and really quite easily do that. But the probability of an event is the likelihood that an event will occur, and it's a number between 0 and 1. The closer you get to 1, the more likely, or in this case certain, 100% as a percent, 1 as a it's actually as a decimal. So that's certain. It's impossible if it's 0. If you're at 50% or 0.5, you're equally likely to occur as not likely. It's a 50-50 chance. So there's a lot of stuff here. You can read through it in the book. I'm just going to go through these problems because I think you really will get this no problem. So you wanted to find the probability that a point chosen at random is on PQ and on RS. So we need to find the length of RS, and they have this whole formula here, but you can basically say from -2 to 4 is 6 spaces, and from P to Q is 10 spaces. So it's a 3 out of 5 chance as a fraction, 0.6 as a decimal, or a 60% chance. Makes some sense. Okay, so in a real-world example, a monorail runs every 12 minutes. The ride from the station from the station near your home to the station near your work takes 9 minutes. One morning, you arrive at the station near your home at 8:46. You want to get to the station near your work by 8:58. Okay? Which means, since it's going to take 9 minutes, you need to be leaving the station by 8:49. Because if you leave by 8:49 and it takes 9 minutes, you'll get there by 8:58. So if the train comes at 8:46, 8:47, 8:48, or 8:49, so 46, 47, 48, 49, any of those minutes, you'll get there by 8:58, okay? Now, since it hasn't come at 8:46, it's 3 minutes that it can come out of the 12 minutes possible, okay? So basically a 25% chance that it will arrive. Now we're going to go through some guided practice. Find the probability that point chosen at random, PQ, is on the given segment. So P to Q is 10 spaces. R to T is 1 space. So 1/10 or 0.1 or 10%. Okay, once again, PQ is 10, T to S is 5. So 1/2 or 0.5 or 50%. Okay, you get the point of these. I'm going to just pull these away so you can check your answers if you really want to do them. Okay, now in example 2, suppose you arrive at the station near your home at 8:43. So you get there 3 minutes earlier. So now, if it comes in the next 6 minutes, and it comes every 12 minutes, we know for sure, so you have a 50% chance. The diameter of the target shown at the right is 80 centimeters. The diameter of the red circle on the target is 16 centimeters. An arrow is shot and it hits the target. If the arrow is equally likely to land on any point on the target, what is the probability that it lands on the red target? Understand, in the real world, the likelihood that it lands is going to have something to do with how well you actually shoot the target. But basically, you're going to find the area of the red circle, and it's easier on these just to use pi because the pi's would cancel out. So 64 pi over 1600 simplifies to 1 out of 25, or there is a 4% chance that you will hit the target. In a scale drawing, your dog dropped a ball in the park. Scale drawing of the park is shown. It's broken into sections. If the ball is equally likely to be anywhere in the park, estimate the probability that it is in the fields. So first you have to find the area. This shape is a rectangle, okay? So the field is 10 by 3 or 30 square units. Find the total area of the park. Count the squares that are fully covered. There are 30 squares fully covered, okay, in the field and 22 in the woods. So there are 52 fully covered. Make groups of partially covered squares to the combined area of each, okay? So you're going to guesstimate here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But they kind of combined to get that there was about 6.5. Like this looks like a whole one, so that's 1. And I would say those two together make 2. And maybe this and this little thing here makes 3. And maybe those two together would make 4. And those two together would probably make 5. I would say it's more like 6. But you get an idea. So the area of the field divided by the total area of the park, or about a little bit better than half chance that the dog would drop the ball in the field. For guided practice, in the target example 1, let's say each ring is 8 centimeters wide. Find the probability that an arrow lands in the black region. So, this is 8. This is 8. I'm assuming that's 8 is what they mean here. 8 and 8. So you actually now in this one have to find the area of the red circle. I'll actually do red and white and this white circle and subtract them from the total. And you would get 14/25 or 56%. And in example 4, estimate the probability that the ball is in the woods. Well, that would have been the opposite. If there was about 51% chance, a little bit greater than 51% chance that it's in the field, there's a little bit less than 49% chance that it's in the woods. And now it's time for the daily homework quiz. I said this is a very easy lesson. So find the probability that a point chosen at random is on Jn and Kn. So J to N, these are skipping, is from -5 to 2. So 7 spaces long. And K to N is 5 spaces long. So 5/7, or if you did that in calculator, 71.4%. Find the probability that a randomly chosen point in the figure will lie in the shaded region. So if this is 4, okay, this is a square and that's a circle, and that's 4, okay? So this is going to be 4 radical 2. So 4 radical 2 times 4 radical 2. 4 times 4 is 16 times radical 4, which is 16 times 2. So the area of the square is 32. Now for the circle has a radius of 4. 4 squared is 16 times 3.14, 50.24. Obviously, because I'm using 3.14, not pi, I'm going to have some rounding issues here. Minus the area of the square. So I'm left with about 18.24. They wanted probability. 18.24 out of 50.24 equals about, well, same thing even with rounding, 36.3%. Okay, a bird is equally likely to be anywhere in the garden shown below. What is the probability the bird will be in the vegetables? 1, 2, 3, 4, 5, 6, 7, 8 times 3. So the vegetables have an area of 24. The whole thing, okay? So this was 24, 5, 26, 27, 28, 29, 30, 31, 32. 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. I'm going to group these together and call them 45. I'm going to group this and call it 46, 47, 48, 49, 50. I'm going to call it about 51.5. So 24 divided by 51.5. So about a 46.6% chance, which rounded to 47. They counted as 51, not 51.5. And that's all their lesson is. Here are the problems from which you can get your homework. But you should be able to do this. Hope you're having a lovely time while I'm in San Francisco.